Hello everyone, this is Mix K. Today we're going to be going over how to balance chemical equations. So first off, why do we care about balancing chemical equations? So what we're trying to do is make sure our reaction is following the law of conservation of mass, or the law of conservation of matter, where the amount of reactants and the amount of products are equal to each other. Now when I say the amount of reactants and products, I'm talking about how many of each atom we have. So we need to have an equal number of atoms on both sides to have it follow the law of conservation of matter. So just a reminder, the law of conservation of matter says matter cannot be created or destroyed. It can only change form. So that means those atoms can break apart from each other, they can break their bonds, they can rearrange, and they can come back together, but we can't change how many of each atom we have. So we can't just make an oxygen magically appear, or we can't just make a carbon atom magically disappear. Now, what we use balanced chemical equations for is doing more calculations in the lab. So if you're going to do any type of science, you're going to at some point or another need to make a calculation in the lab using a chemical equation. And what it does is it helps you predict how much reactants you might need to make a certain amount of product. It might help you predict how much product you're going to make total. It might help you figure out, the ratios you need for a certain experiment. So like, for example, when I worked in a research lab, I would need a certain amount of product to test. I would have to run all these different tests on it, and so I would need to make sure I had a certain amount. So I wouldn't want to waste any. So I would calculate backwards and figure out how much of my reactants I needed to start with to make the amount of product that I needed. You can also use these to figure out if you're missing any product. So if you don't get the amount of product you're supposed to get, you can use this equation to help you figure out how much was missing and what might have gone wrong. So balancing chemical equations is kind of like a puzzle. Now let me pull out the examples I actually wanted to go over. We'll start right here. Okay. And as we go through this, we're also going to just review the types of reactions. So for each one, we're going to go over what type of reaction it is, and then we will balance it. So for this first one, we have hydrogen plus oxygen. Oop, my arrows are missing, so I'll draw those in as I go. Producing H2O. So here we have two things combining to make one product. So this is a synthesis reaction. Okay? Now, the first step is we want to separate our reactants from our products. Just making sure you guys can see. Yep. And so at the arrow is what separates our reactant side from our product side. So we're going to draw an arrow down, or a line down, separating them. Okay? And the next thing, we want to list the elements that we have. So here I have hydrogen and oxygen, and I'm going to write them in the same order because I'm going to want to keep track of how many I have. Now, when we're doing this, we want to assume that we're starting with one of each, because if they're in the reaction, there's going to be at least one of them. If there's zero, then there's nothing there, so it wouldn't be there. Okay, so what I'm going to assume is that each of these lines has a 1 on it for right now. I'm just pretending. If it's blank, it means 1, because chemists don't write in the ones. They figure if you wrote that symbol there, you know you at least have one of it, because if you had 0, it wouldn't be there, right? Now if I look, I have H2, so that means I have 2 hydrogen atoms on this side right now. And I have O2, which means I have 2 oxygens right now. Then when I look at this side, I have 2 hydrogens, but I only have 1 oxygen. So what we need to do is we need to put in numbers here to make the amounts of each atom equal. So these numbers that we're going to put in are called coefficients. Just like a coefficient in math class might be like 2 times x plus y, right? This is your coefficient. You're going to multiply it by all the parts in there. So that would mean I have 2 x's and 2 y's. So if I put a number here, it's going to change both parts of that compound, if it is a compound. So when we plug them in, we're going to be multiplying to try and make both sides equal. So right now, both my H's are the same, so I don't want to change those. But if I look, my O's are different. So I want to change the side that has less to equal the side that has more. Now I'm not adding, I'm multiplying. It's a coefficient. So what I'm going to do is, what number do I need to multiply by 1 to equal 2? It's 2. So I'm going to put 2 here. So first, this is going to change my O. It's going to do 2 times 1 is now 2 of those. And it's going to change my H. Just like up here when I did my foiling, I think. No, not foiling. Whatever. Multiplying. Okay? So 2 times 2 is now 4. So now I've made up my oxygens match, but in the process, I've made my hydrogens mismatch. So now this side has 4 and this side has 2. So I need to think of what number do I need to put in front of H to make it equal to 4. So if I put a 2 here, I'm going to have 2 times 2 is 4. Now I'm going to leave the spot in front of O blank. It technically means 1. But when we look now, we have the same amount of H's and the same amount of O's. So it is balanced. Okay? Let's look at another one. So if we look over here, I got to draw my arrow in because they didn't come up for some reason. Okay? So here I have an element and a compound. And at the beginning, my element is by itself, zinc. But at the end, it's with chlorine and now hydrogen's by itself. So if I have a single, sorry. Sorry about that, guys. If I have a single element coming in and switching with part of a compound, this is going to be a single replacement reaction. Okay? Single element switching in. Okay. Now, I'm going to draw a line down. Okay? And I'm going to list my elements. And I want to make sure I list them in the same order so I can keep track more easily. So I have zinc, I have hydrogen, and I have chlorine. Zinc, hydrogen, chlorine. Okay, now I need to list how many I have on both sides. Now, a couple tips before we do all this. When you're balancing, you want to do one type of atom at a time because if you try to do all the atoms at once, you're just going to get confused. The other tip is you want to start with elements that are only found once on each side because that's going to make it easier to balance because they aren't changing multiple places. If you have a lot of elements, you kind of want to save hydrogen and oxygen for last because they're so common. They are found in a lot of places, so it's going to be easier to save those for later. We'll talk about polyatomic ions in a minute. And don't forget to multiply the subscript by your coefficient when you're doing your math. Don't add it. The last thing, and I didn't put this here, it has to be whole numbers. You can't use fractions or decimal numbers. They have to be whole because you can't have half of a molecule. If it's half of a molecule, it's not that molecule anymore. Okay, back to the problem. So right now there's no number here. So that means we have 1 zinc, we have 1 hydrogen, and we have 1 chlorine. Over here I have 1 zinc, I have 2 hydrogens, and I have 2 chlorines. So right now my zincs match, so I'm not going to mess with those. So let's pick chlorine to do next. So I need to change the side that has less to make it equal the side that has more. So right in front of where I see chlorine, I'm going to put a 2 because I know I need 2 over here. So I'm going to have 2 times 1 is 2. Now because these are bonded, I'm saying I have 2 of this entire group. So I'm going to also need to have 2 of these. Now if we look, zinc matches, hydrogen matches, and chlorine matches. Okay? So our goal is always to get them to match. We leave the rest of these blank because that would mean 1. Now let's look at one that has a polyatomic ion. So a polyatomic ion is a group of atoms that are bonded together. Now if we look here, we have OH and we have NO3 and they're in parentheses. So they're kind of their own little group. Now what we can do is if we see that polyatomic ion on both sides, we can leave it as a group because polyatomic ions tend to stay as groups and move around as groups together. So when I go to draw my line down right here, I'm going to list them as their own thing. So I have H, I have NO3, I have Mg, and I have OH. Now over here, I don't see OH, but we can actually rewrite H2O as HOH, like that. Okay? So we can see that OH in there now. Now if you look, we have H on the outside and H on the inside. What we can do is keep track of that by just adding like a little line to help us remember that we're keeping those separate. Or you can just keep track. It doesn't make a difference. So I have H, NO3, Mg, and OH. Now the point of doing it as polyatomic ions is it's going to make your balancing easier. So if you look, we have H's in multiple places and we have O's in multiple places, but if we separate them, we can keep track of them more easily. So over here, I have one H on the outside. I have one of this NO3, because 3 is part of it. I have one Mg, and I have two OHs. Over here, I have one H. I have two of these NO3s, one Mg, and one OH. So let's start with something that doesn't match. So right now, my NO3s don't match. So I'm going to go with the side that has less, and I'm going to change it so that it is equal to the side that has more. So what number times 1 will equal 2? That's 2. So now I have 2 of these and 2 of my H's. Okay, so now I've made my NO3s match, but my OHs don't match yet. So I'm going to change the side that has less to equal the side that has more. So here I'm going to do 2 times both of these. Okay, so 2 times OH means this is going to be 2 now. 2 times H, and that's going to be 2 now. So if I look, that matches, that matches, that matches, and that matches. Now we forgot to do the type of reaction. So here, if we look, H and Mg are switching partners. To start, H is with NO3, and then at the end, it's going to be with Mg. Or Mg is going to be with NO3. And H is going to end up with OH. So if there's 2 compounds swapping partners, this is going to be double replacement. Okay. Let's try another one. So this one here, we can see we have something with carbon plus oxygen producing CO2 and H2O. So this is a combustion reaction. Now combustion reactions can be a little tricky because they have carbons, oxygens, and hydrogens, and the oxygens are in multiple places. So we need to think about adding those amounts together. So I have CHO. So here, and I'm going to have the same thing over here, CHO. So I have 1 carbon, 4 hydrogens, and 2 oxygens. Over here I have 1 carbon, 2 hydrogens, and now I have to add, because I have oxygens in 2 places. So I have 2 from here, plus 1 from here means I have 3 total. Okay? Now I wrote this like this because I want to keep track of where those oxygens are coming from. Now my hint for combustion reactions is you want to start with your carbons and then your hydrogens and then save oxygen for last. Because oxygen's in so many places, it can get a little complicated. And also over here we have oxygen by itself, so we can put pretty much anything here to make it match up. So if I go to my hydrogens, I have 4 over here and only 2 over here. So I need to put something in front of this that will multiply it to equal 4. So 2 times 2 is 4. Now, we also have to multiply the oxygen, but what we need to think about is we're only multiplying this oxygen here. We're not multiplying the ones over here. So we can't just multiply this whole thing and say it's 6, because we didn't change these ones. So instead, we still have 2 from here, plus 2 times 1 is 2. So now we have 4. Okay, now our last step, we need to make the oxygens over here match. So we need to think about what number do I need to put here to make them equal. So if I have 4 here and 2 here, if I put a 2 times 2 is 4. So I have 1 carbon, 4 hydrogens, and 4 oxygens. Okay? Now these can get trickier. Let me find my next example. Yep, okay, here we go. So these are both combustion reactions, okay? And I'm just showing you 2 examples of them because they can be a little tricky at times. Okay, so here it's still carbon, hydrogen, and oxygen, carbon, hydrogen, and oxygen, but the amounts are going to be different. So I have 2 carbons, 2 hydrogens, and 2 oxygens. Let me make sure you guys can still see. Yep. Here I have 1 carbon, 2 hydrogens, and then I have 2 oxygens from here and 1 oxygen from there. That equals 3. Okay, so let's start with my carbons. To make my carbons match, I have to put a 2 here. So 2 times 1 is 2. Okay, but this is also going to change these oxygens. So now I have 2 times 2 is 4, plus the 1 from here is 5. Okay, now here we've hit a snag. if we look, our carbons match, our hydrogens match, but our oxygens don't. We have a 5 here and 2 here. Now, I've already told you we have to use whole numbers. So if I try to put a whole number here, I'm not going to be able to get 5 because 5 is odd, and we're going to have to multiply it by 2 because if I do 1 times 2, I get 2, 2 times 2 is 4, 3 times 2 is 6, and now we've missed our mark. So what we need to do to make this work, we have 2 options. The first one is we can put a temporary decimal number here. So we can think about what is the decimal number I can put here to make it multiply to equal 5. So I can put 2.5 times 2 equals 5. But the problem with that is I'm not allowed to keep this decimal. So what I'm going to do is I'm going to multiply everything by 2. And when I multiply everything by 2, everything will stay balanced, but I'm getting rid of this 0.5. So I'm going to change this to 2. I'm going to change this to 5. I'm going to change this to 4. And I'm going to change this to 2. So I just multiplied everything by 2. So now let's go back and double check our numbers. So here I have 2 times 2 is 4. Here I have 4 times 1 is 4. So my carbons match. Here I have 2 times 2 is 4 hydrogens. Here I have 2 times 2 is 4 hydrogens. Now let's look at our oxygens. I have 5 times 2 is 10. And here I have 4 times 2 is 8 plus 2 times 1 is 2. So I had to do the work to make sure that those would match up by multiplying everything by 2. Okay, so that made this able to multiply to an even number instead of an odd one. Let's try another one. Now this one's tricky because oxygen is literally everywhere. Okay, so we still have carbon, hydrogen, and oxygen, but now we really need to think about those oxygens because they're all over the place. So here I have 6 carbons, 12 hydrogens, and I have 6 oxygens from here and 2 from here. So now I have 8. Over here I still have 1, 2, and then 2 plus 1 is 3. Okay, so let's start with our carbons. Okay, we have 6 here and 1 here. So I'm going to change the side that has less. I'm going to multiply it by 6. So it equals 6. But that means I also have to change the oxygens. Now remember, I'm not multiplying this whole thing by 6, just the first part. 6 times 2 is 12, plus the 1 from here is 13. Okay. Now let's do our hydrogens. We have 12 here and 4 here, or 2 here. Sorry, I'm messing up my numbers. So here, we need to make them match. So I'm going to change the side that has less to equal the side that has more. So 6 times 2 is 12. That means I'm also changing these oxygens now. So I still have 12 from here plus 6 from here is 18. Okay, last step. Now here's the tricky bit. We have 6 oxygens here already. And I don't want to change this because it's going to make my carbons and hydrogens also change, and I just worked very hard to make them all match. So what I'm going to want to do instead is only change these oxygens here because those are only oxygen. It's not going to change carbon or hydrogen. So here's what I got to do. I still have to keep track of this 6. So I have some number plus 6 has to equal 18. So whatever I get here has to add it with 6 to equal 18. So that's going to be 12. 12 plus 6 is 18. So what number times 2 equals 12? 6. So we have 6 times 2 is 12, plus the 6 from here equals 18. So we need to think about those oxygens all the way throughout. You got to make sure that if there's an element in multiple places, you're keeping track of it and adding them together each time. Okay? Okay, so that is my video on balancing chemical equations. I hope you feel like you have a little bit of a better understanding. Don't forget, you can always email me with questions or concerns. Let me know if you have any other problems. And thank you so much. Have a great day, guys.